Okay. Um, Anybody else? Or Michaela, if you have another question, there's two Michaelas, either Michaela or Karen.
I have a question. So for the math practice, can you hear me?
Yeah.
Yeah.
Okay, awesome. Okay, so for the math practice sheet, I had a question about the math spring model. Like, I don't understand, like, what is
Yeah.
going on with that?
I really quickly before I answer your question, for everybody else, there's a part of the math practice sheet that is like open quotient and stuff like that. That's for the next exam. So like math practice sheet is stuff you're going to use for the whole class. And so if there's stuff on there you haven't seen, don't worry about it. But Math Spring we have seen. So let's talk about that really quickly. Um, Let me pull up my version of the practice sheet. Okay. That's obviously not the right page. That's the QO stuff that you don't need. Oh, they're all here. Never mind. Sorry. I forgot what I did to make this. Okay, so mass spring model has a resonant frequency of 1430. What's the frequency when stiffness increased by a factor of 25? And then this is too long for me to read what else it's talking about. What if the mass is increased by a factor of 100? Okay, so the mass spring model, let me see if I can write. Yeah. That's the one where you've got resonant frequency equals square root of K
Wait,
over M.
I have something different on my notes.
Do
I
you
have
really?
it, yeah, it's like FR equals like 1 over 2 pi times the little thing and then the K divided by
Oh, am I
M.
missing? I'm leaving out this part right here.
Yes. I was like, wait,
That's
no.
okay. That's okay, because you don't have to use that part, actually,
Oh,
which is why I never remember to write it down. But I should. So what did you say it is?
it's like FR equals 1 over 2 pi.
Oh, that's right. 1 over 2 pi. Okay. You don't have to worry about the 1 over 2 pi. I mean, you can, but like, why? Um, so what you're going to do is this is like the base formula. So what you're going to do is you're going to take, let's see, a mass spring model has a resonant frequency of 1430. So in this case, we'll write down 1430. And then that equals all this, the 1 over 2 pi and the K over M. But the only thing that we're changing in the first question, this one right here, what is the frequency when stiffness increases by a factor of 25? Do you remember which one is stiffness and which one is mass?
K is stiffness and M is mass.
Yes, exactly right. So if stiffness is increasing by a factor of 25, we're taking this formula right here and we're just going to like pop in a 25 right here, 25 times K. So you can do all that like high school math class stuff to see how this is going to change the 1430. But essentially what's going to happen is, let's see. We can pull the 25 out. So what we're going to do is we can rewrite this portion right here as square root of 25 times the square root of K over M. And then the 1 over 2 pi is there as well. So I'm gonna make a big slash right here so we see if this is not part of the same formula. This is just rewriting that. So if you've got 1430 equals this, you're raising this by a factor of 25. You're going to kind of have like a second formula here, which is 1430 times x equals 1 over 2 pi. Let's get rid of the 25 from here since we see what's going on with it. 1 over 2 pi times 20, the square root of 25 times the square root of k over m. So we're kind of just rewriting what's going on here. Here's the formula we have. We're going to increase this by a factor of 25, which gives us this new thing. Increasing by this factor of 25 here is going to mean we have to multiply by something on the other side. We don't know if it's, we don't know what it is yet, but we're going to figure it out. So square root of 25 is 5. So we can get rid of this and write it as 5. And then we can just start like crossing stuff out, right? So like k over m, square root of k over m is right here, square root of k over m is right here. So we can cross those out, ignore those. 1 over 2 pi, 1 over 2 pi, we can cross those out and ignore those, which means that 5 is this x. So we're just going to multiply 1430 by 5, which is, I don't know, something big.
$7,150.
That sounds right. Yeah, 7,150. And then for the next part, for this part right here, it's kind of the same. It's a little bit different. The only part that's different about it is that this is on the bottom of the equation. So let's see, I can write over here. We'll do the same thing. We take 1430 equals the 1 over 2 pi times, and then we're gonna break this. Well, no, we're gonna write the regular equation first, times k over m. And then we're gonna do the new one, which is 1430 equals 1 over 2 pi. And then the mass is increased by a factor of 100, which means we're putting 100 down on the bottom of the equation. So it's like 100 times m. If you pull this out, last time it was just 25, and then we took the square root of it, and it was 5. But because this is on the bottom of the equation, it stays on the bottom. So it has to be 1 over 100, square root of 1 over 100 times square root of k over m. And then once again, we're just going to like cross all the stuff out that's the same. So we can cross out the square root of k over m. We can cross out the 1 over 2 pi. What we're left with is 1430 x is the square root of 1 over 100. We're going to put this x as 1 over 100. We have to figure out what that is. So the square root of 1 is 1, and the square root of 100 is 10. So this ends up being, oh no, I was trying to write another square root. It's 1 over 10. And if you multiply this by 1430, it's just 1430 divided by 10, which is 143. So the answer should be 7,150 and 143, which I did not rewrite. Why did I not do that? Okay, there we go. 143, 7,150. And then if we look at the answer key, I have to stop writing. There we go. Answer key is 7,150 and 143.
Okay, so I have a question.
Go
So
ahead.
when you first like write it out, the 1,430,
Yeah.
and you rewrite it again, so is that how we're supposed to do it? Like write it first out and then rewrite it again when we plug in like the values that were given?
Yeah, you mean like to show that you're showing your work and stuff like that?
Well, yeah, because you're crossing it out. So it's like,
Yeah.
do we need it or like,
You need something to kind of show that you're because in the exam you'll have to show your work so that I know that you're not just copying from somebody else. So you can write it out like that. It's an easy way to write it out. You can also just show that it's like 100K or 100 M square root of K over 100 M. And then you can just say like equals square root of 1 over 100 times square root of K over M, and then just move on to 1430 over 10.
oh,
So you don't have to do the whole thing. You can, but you don't have to show the whole thing. Do you understand how the process went though?
yeah, I understand. Just wasn't too sure like why you wrote it 2 times. So, but now I see
Yeah,
it looks easier, I guess. You get to cross out everything. Sorry, my dogs.
that's okay. That's okay. Um, I mostly do the crossing out, writing it twice and crossing it out just to like to teach it in case some people aren't seeing how you get from one to the other. If you're understanding it, you don't have to do every step. But you just have to show some of the steps, just enough to like show how you're getting from one place to the next. There's really not a lot of work on that question because it's just what's the square root of the thing and then either multiply it or divide it. So not a big problem. One other thing that you guys will see in this is you're also going to get a question. What happens when the resonant frequency is increased by a factor of 2 or something like that? And all that is just like multiply the resonant frequency by 2. So if the resonant frequency is 1430 and the resonant frequency increases by a factor of 2, it's 1430 multiplied by 2. So it'd be 2860. So don't get tripped up on that one.
So you said the that what increases the stiffness or the mass?
For that third question, it's just going to say the resonant frequency
Oh,
increases.
okay.
So that you don't do anything with the formula. You just multiply the resonant frequency.
I don't really have a specific question to ask, but can you just give us an overview of like what we should be focusing on?
Yes. So for the hand calculation portion, this math practice sheet is like totally your friend. It's exactly the kind of questions you're going to get. Not the QO stuff, but everything else is the kind of questions you're going to get. Yeah, some of them are like exactly like the questions you're going to get. So what are the second and third resonant frequencies of a tube with 2 open ends? Then I'm going to say that it gets closed at one end and what happens to it. So you just have to calculate these. Helmholtz resonator, you're going to get those questions. Mass spring, you're going to get questions like that. Period and frequency, I don't think you have any questions like that in hand calculations. That's mostly done in the multiple choice because it's like easier stuff. There's one question in the hand calculations that it uses exactly the same stuff that you're learning here. It's just like it's written differently. So it's in one of the math practice videos, but I think probably the most recent one. Um, it is just going to ask you like a tube has a length that's increased by a factor of 4. A tube with a second resonant frequency, that's what it is. I'll write it down here so you can copy the wording if you want to. So a tube with a second resonant frequency of 100 has had its length increased by a factor of 2. What's the new second resonant frequency? So it's kind of just like you have to do the calculations twice, right? So you have to find the length of this first tube, and you're just given the second resonant frequency is 100. So we can run through this really fast. If I go too fast running through this, you can stop me and slow down. And if you're going along with it, then that's cool. But you'll do resonant frequency equals, let's see, it's the second one, so it's going to be 2n minus 1. So it's 2 times 2 minus 1. Multiplied by 340 over 4L. We're looking for L. We know everything else. We actually know resonant frequency, so I shouldn't have typed it in as RF. It's 100. So 100 equals 2 times 2 minus 1 times 340 over 4L. This is going to be 3. I think 85 is what this becomes. 85 over L. And then what we're going to do is you can multiply 85 by 3. Get 255. So 100 equals 255 over L. Multiply both sides by L. 100L equals 255. Divide this side by 100 and this side by 100. You get L equals 255 over 100, which is, well, probably 2.55. Yeah. But then you're not done. You have to take that 2.55, multiply it by the factor of 2. So that means that it's 5.1. Now your L's 5.1, and you have to find the new second resonant frequency. So now you're going to do RF equals 3 again. 2 times 2 minus 1 is 3. Multiplied by 340 over 4. And this time we know the L is 5.1. So I'm going to multiply 340 by 3 to get 1020. And 4 times 5.1 is 20.4. And so the new second resonant frequency is 50. Ta-da. And then you're done. Which is all the same math from all the other questions. it's just the way it's worded is it wants you to run through it in two different formulas. So that's one thing to expect. This page and then that other type of question.
Is
The Go ahead.
sorry. Is
No,
the
you're
written is the written exam, is that one timed?
The no. You mean the hand calculation ones?
Yes.
No.
Okay.
Not timed at all. It's just I mean you have to finish it by midnight on the 6th, but other than that, no, you're good for
Okay.
like leave it open for an entire day. That's okay. The other one is timed though. I think it's 45 minutes, maybe 90 minutes, something like that. But it is going to look a lot like the knowledge checks. So if you've been doing the knowledge checks, you're very familiar with the kind of questions that are going to come up in the exam. One or two of the knowledge check questions are exactly the questions that come up in the exam, and all the rest of them look like them, just with different numbers. So you've seen it all before in the type of question that you're going to get. There are no questions about like what you're doing in Audacity and Pratt and stuff like that. That's just totally outside of the exam. All
I
right.
don't think I have any other questions.
Okay. How are you feeling about it?
I mean, okay.
Okay.
What would you recommend us doing for our cheat sheet? Like, what can we put on the cheat sheet for the math?
For the math part.
Because we don't
Oh.
get that for the multiple choice.
No. Well, for the math part, you've got like it's totally open note.
Okay.
So you can use anything that I've given you. Theoretically, you could even like watch the math review videos once you get the questions. You just have to know how to like where to put your numbers in.
Mhm. Do we have to show you our notes or anything or?
Nah.
Okay.
No, you just have to show your work on the sheet that you turn in.
Okay.
Are we like taking like a screenshot of it and then like uploading it, or?
Yeah, you can do it however you want. A lot of people like work it out on paper and then just like snap it with their phone and upload
Okay.
it. Like instead of going to the exam on their laptop for this part, they just go on their phone and then they'll just upload the questions from their
Mhm.
phone.
Okay, so like if we wanted to like write it on a piece of paper, we can do that and just take a picture and upload it.
Totally. Yeah.
Okay, so
Whatever is easiest is totally fine.
I just want to make sure I don't do anything wrong.
No,
And
it'll be
upload.
fine.
Yeah. Can you go over it was on your let me pull it up on mine and the about the tube. So I
Yes.
see on our thing it has one that has been closed on one end. So how are we? Yeah, I'm a little confused about that.
Okay. That's all right. Let me bring this guy back up. So the difference between tube closed at one end or no ends, the formula is a little bit different. Speed of sound is the same, right? Speed of sound is always 340. So make sure that you use 340 as your speed of sound. But then if you have two open ends, one of the big differences is that's every harmonic. Every harmonic's at play in a tube that's open at two ends. So it's just N, right? Part of the formula just has N. N times 340 over 2L. And so what that means is you just take the length of the tube, multiply it by 2, divide 340 by that answer that you just got, and then multiply that answer by whatever harmonic you're looking for. So if you're looking for the first 4 harmonics of a tube that's like, let's say 0.15, let's just do 0.25. That's so easy. So we're going to do first 4. Of a tube that's 0.25 meters. So what that means is we're going to ignore the N for now and just solve this right here. So you're going to go 340 divided by 2 times 0.25, which is 0.5. So 340 over 0.5, which is going to be 680. And then kind of keep that number right there. We want first 4 harmonics. So we're going to multiply this number by N, and N is the number corresponding to each harmonic we need. So it's going to be, if we need harmonics 1, 2, 3, and 4, it's just 1, 2, 3, and 4. So 1 times 680 is 680, 2 times 680. Psh, I should have planned this out before I did it, or made it easier on myself. 1360. 3 times 680 is 2040. And 4 times 680 is 2720. And so there's the first 4 harmonics of the tube that's closed at, oh, what the heck did I just do? The tube that's closed at no ends. It's open at both ends. Okay, so then you close the tube. Only one is open, or one is closed, whichever. That changes the formula to be 2n minus 1 instead of just n. So now what that basically does is if you have the first harmonic, it's 2 times 1 minus 1. That's still 1. Okay, great. First harmonic is 1. But then when you go to the second harmonic, 2 times 2 is 4, minus 1 is 3. So now we're looking for harmonics 1, 3, 5, 7. If we want the first 4 resonant frequencies, it's no longer just every harmonic that we're counting up. It's now the odd harmonics. So that's what happens when the tube closes at one end. Close at one end. And then we're also going to see that there's a change in this portion of the formula too. So now it's 340 over 4L. I have to multiply the length by 4 now instead of by 2. So if you're solving for this, it's pretty much the same thing. Focus on this part first and then go back to this. You'll do 340 over 4 times 0.25, which is 1. And 340 over 1 is just 340. So there we go, 340. First resonant frequency is harmonic 1. 1 times 340 is 340. Cool. That's easy enough. Second harmonic is going to be 3, not 2, even though it's the second harmonic. And that's because 2 times 2 minus 1 is 3. So then you multiply 340 by 3, 1020. Third harmonic, 2 times 3 is 6 minus 1 is 5. So you're going to multiply 340 by 5, which is 1700. And then fourth harmonic is 2 times 4 is 8, minus 1 is 7. So 7 times 340 is 2380. So there's your answer for that. Same length. And it's just that what's changed is one of the ends closed. And it changes the formula a little bit. So 2 ends open, 2L, 1 end open, 4L. And then also with 2 ends open, it's just N, and with 1 end opened, it is 2N minus 1. Did that answer your question?
Yeah, yes, it did.
Okay. All right.
It seems like a lot, but I'm just gonna practice.
It does. It does. It does seem like a lot. The reason this could come up as one of the questions in the multiple choice part, the reason it's 2L versus 4L is if you have if they're both open, you can just fit like half a wave in here. Oh man, totally screwed up on that. But there's half a wave. So to get to the full wave, you just multiply that by 2. When one of them is closed, then you're going to start. See how this starts like at a node right here, and then it ends at a node? That's why you can only start and end at a node. So you can do half of a wave. The lowest you can do when it's closed at one end is you're going to have to start at the middle here. So you can come from the middle and go up, and you can fit a quarter of a wave inside of that. If you can fit a quarter, you can also fit a half. You can also fit, well, you can't fit a half actually, because a half is node to node. You can fit 3/4 of a wave. So you could like start here, hit this, come back down, and then get almost the full wave in. If I could figure out where my freaking, there we go. Okay, so you could start here, come down. What? Oh man, I'm so bad at art. It's gonna look like that. It's so bad. Anyway, you come down and come back up. So that's 3/4 of a wave. It's supposed to be 3/4 of a wave. It doesn't look like it, but it's supposed to be. That's why you have all those like odd harmonics. 1, 3, 5, 7 over here, and then here it's just 1, 2, 3, 4, because you're not at a portion of a wave. You're at like a half, and then a full, and then 1.5, and then 2 full waves. I won't clear those yet in case you're taking notes on them. I'm gonna try to, there we go. Anyway, you don't need to know that for the hand calculations. It could come up on the multiple choice portion. There's like a whole bank of questions that you might get, like 100 and I think I have 120 questions that it pulls from, so I have no way to know exactly which ones you're going to get, but that's one of them. Has anybody seen this like pickle thing at Sonic? It's like a pickle slush.
Yes, have you tried it?
I have not. Have
I'm a
you?
huge pickle fan.
Oh my, I heard about it, but you know what? There's a Sonic nearby me in my area is does not exist. It takes like I think 45 minutes to 50, but whoever tried that pickle slushy, I'm jealous.
Yeah. Did you try it, Karen?
No, I'm surprised I haven't. Me and my old coworker, we send each other like pickle memes all the time. And there's actually at one of the I live in St. Louis and there's an overpass of the highway that someone will put a random bar or a random jar of pickles, and it's like known as the jar of pickles on Manchester in De Pere. Like it is hilarious. But no, I will have to try it this weekend and I'll let you know how it is.
Okay, yes. Please
Oh,
do.
oh
Yeah.
yeah, so Sonic near me is an hour and 8 minutes.
What?
Oh,
Yeah, I know, because I live in in LA, and then the closest one is in Norwalk. I don't know if you guys,
Yeah.
yeah. So if you guys ever try it, let me know. I might drive there one day. Just try the pickle.
Just
Try the pickle slushy.
I have a Sonic that's literally like 2 minutes away from my house, if even that, like right around the corner. But I don't know, I'm not a fan of Sonic like that.
I heard
I'm
it's
a fan
It's
of
okay.
pickles.
Have you guys
Yeah.
tried In and Out?
Oh
We don't
yeah.
have
Yes.
those here.
What?
Yeah. I mean, I've definitely been when I've gone. I was out in Arizona a couple years ago. That's where my husband proposed to me in the Grand Canyon. So we definitely, our first stop was In and Out.
Yes.
Oh my god, I thought you said he proposed to you at In and Out for some
Oh, no.
reason.
I mean,
Imagine free burgers for life.
yeah.
Yeah,
I was
right?
like, oh, I hope the workers gave you some burgers for free. That's funny. How we get from waves to this, from
I know.
pickles into In and Out. That's funny,
I needed that for a Friday night.
right?
Yeah, yeah.
Are you guys horror fans?
Oh yes.
Oh yeah, are you gonna see the new Conjuring movie?
I'm way more excited about Toxic Avenger.
Toxic Adventure. Let me look that up.
You should. Peter Dinklage is in it. It's like horror and comedy. It looks great.
Oh, Peter Dinklage.
Yeah.
Or Dink. I don't know how to pronounce that.
Yeah.
And Kevin Bacon.
And Kevin Bacon.
Wow.
Yeah.
Elijah Woods too. Oh my god.
I'm telling you, man. It's like, and if you should watch the trailer because it looks hilarious, and then also there's just so much gore. It looks great.
I do like gore. I'll definitely check it out.
Okay.
But this might be I do have a curious question about sounds and everything.
Yes.
So sorry guys, I know we tracked off from an exciting topic of pickles and horror. But I work for someone who has what's it called? She has cameras in her room, and I take one of the cameras wherever I need to go because unfortunately she's like someone who could fall and stuff.
Oh
But
yeah.
but I take the camera and I always put it on loud. But what's interesting is that whenever she watches TV, I hear from my own ears the sound from the TV first, and then the sound comes out of the monitor. Why is that? Like, why is it that I hear the sound first before it reaches to the monitor?
That is because air, the sound pressure wave in the air
Uh-huh.
is moving way faster than the transmission speed of the camera. So I'm guessing there's like some sort of Bluetooth or wireless transmission involved.
Yes.
It's slow. There's a lag in the, it's not slow like once it sends out, but to get the signal and transduce it into from pressure wave into a voltage wave, and then from a voltage wave to a little Bluetooth wave, and then for the other thing to receive it and transmit it back into a sound wave takes more time than just moving through the air.
Okay, I figured that was it because I know from last week's module, I think you mentioned about cancellation speakers,
Yes.
and it kind of reminded me of that. I'm just like, huh, I wonder if it works the same. But now that Bluetooth or wireless, because it is wireless, I could take it wherever I go, and so I'm like, I wonder if it works the same because I hear the sound first from my ear, and then like a second later it comes out.
Yeah. Yep. Totally. I bet there would be a distance away that it would like start to sync up because it, like it takes sound some time to travel. And then all of the transducing is what takes the time. The actual signal traveling through the air is pretty fast. So like if you if you wanted to get her in on like an experiment, you could have her just like turn that stuff way up and see if you can go like out into the street and find the point that they sync up. I mean, it seems like a lot more work than it's worth, but there would be a time when you could get it to sync up.
Yeah, cause in her kitchen, I always put the volume loud because her hearing aids. Well, now they fixed her hearing aids, thank goodness.
Mhm.
And she would put the TV really, really loud. I'm just like, okay, so I go downstairs to her laundry room, and then I still carry the, even though I could hear the TV and everything going on, I still need to hear her in
Right.
case, and even though I'm looking at her through the monitor screen, but I hear like it's a pretty big distance too. So I'm just sitting doing her laundry. I'm just like, oh my god, I hear the sound first and then it's lagging on this thing. So that's
It's
okay.
crazy, right?
Mhm.
Yeah, it's so crazy how sound travels.
Yeah, I love it. It's a weird thing, but it's very cool.
Yeah. See, because I'm still stuck between audiology or SLP, but I'm leaning more towards audiology because I do like the way how sound works. So this class kind of helps with me leaning towards that instead of SLP.
Yes, that's cool. You should talk to Dr. Boss about this if you have had any classes with him, because there's some shakeups in the audiology field. There's a lot of stuff that's like maybe people are getting their hearing aids online and having AI set their hearing aids up. It's not good. Like it's not
Mhm.
going to help. It's going to make people go deaf. But
Mhm.
it could be that you might have a harder time finding a job than you would have 3 years ago.
Mhm.
Oh, really?
Yeah, it's possible. And then at some point, what's going to happen is they're going to realize that this method is hurting people's hearing, and they're going to go back to having audiologists do the setup. And so then there's going to be way more people that we need. So it's hard to predict. And because I'm not an audiologist, I think you should get an audiologist's opinion. So Dr. Boss, are there any others? Dr. Williams, any of those should be
Okay.
able to kind of give you better advice on that, which I know is a bummer since you're like, I think that I like this more, but in the current like tech climate, I think SLP is a little bit more of a safe bet.
Oh, oh man,
I know.
I thought audiology was kind of doing well because like another thing I took your I think
205.
communication, yeah, your
Yeah.
communication disorder, and then you did mention that, oh, it's actually 21 it has gone up 21%, something along the lines
Yeah.
like that. But I
Yeah.
don't know if the statistics are, you know, caught up.
Yes, that's exactly the problem is that we don't have up-to-date statistics on what's going on with the field.
Oh man.
And we might not for a little while. There's like weird stuff going on. But
Hmm.
so you should totally reach out. I mean, you're fine right now. Like all the undergrad classes are all the same, so you're totally good. But reach out to one of them and just get their feeling on like what the future might be like for audiology.
Okay. All right. So Dr. Boss. Dr. Boss.
How you don't
Yeah.
use Q-tips.
Yeah, right. Exactly.
You know, it's funny. I was just telling my coworker about that because she was just like, "Our client's ear is so dirty." I'm like, "Well, a good thing is I'd rather have her ears be dirty instead of us sticking a Q-tip in there because imagine all that buildup of the wax."
Yeah, he says just when you're in the shower, just do a clean like with your fingers instead of sticking things in there.
Yeah.
Oh yeah,
Personally, I still use Q-tips.
I know.
Ah.
Oh yeah, even my coworker just sent me a picture of her hearing aids, her new updated hearing aids. Now we can talk smack about her. No, I'm kidding.
I mean, there's still some, right? Like the cool hearing aids, you can't have AI do them yet, but I don't know. I
need to
don't
know.
know. I don't know enough. It's not my field. So just, you know.
I actually seen on TikTok a video that they had like a AI SLP
Oh God.
and all the comments were just like, is this really gonna take me out of my job? And I was like, oh my.
I don't think it knows enough, bro.
I hope not.
Yeah, I mean, think like I don't know how much. I don't know how much percent of the job, but like a decent percentage of the job is like building a relationship with the kid
Right.
or your other client. And so it's like, what the fuck's the AI gonna do with that? You know,
I
like
know
it's
they're
not
gonna
gonna.
sitting in front of like a computer or something, and that's, I don't know. Like
Yeah,
the computer doesn't have emotion.
exactly. It's not excited when you do well and like encouraging you.
Yeah.
I don't see it,
It
man.
might be there to like help you,
I
but
can see
not
that.
take your place. Not
I
take
can see that. Totally. Oh
like
yeah.
it might be able to catch something that you can't hear, but it's not gonna take over.
Oh, yes, like when they're doing like evaluation.
Mhm.
Yes. It can be trained on like all this stuff that we're learning and help.
Yeah.
Let me show you this.
I currently work for an IT company and we talk about AI all the time, but my boss is always like, it's there to help you be better at what you're doing, not take your job.
Right.
Yeah, yeah.
But you know what's funny? I volunteer at the Phoenix Children's Hospital. So we had one of our volunteers come in um and she works in IT as well, and she was saying that there's not actually a lot of job openings in IT anymore, how there used to be.
Oh.
Because
Yeah.
of AI, huh?
Yeah, I think that's what
That
it is.
and
That's scary.
it's that, and it's also like we don't program anymore, or they get programmers from like the Philippines that are, it's a lot cheaper.
Mhm.
And they
Mm.
can do all that stuff like overnight because the time difference. So I know we have some people that work on our team that are in the Philippines because they're doing the back end stuff that we can't do when like the company's at work. So
Yes.
Yeah.
Yeah, that's kind of scary. Like, I feel like technology should work with us and we should work with them. But if it's to the point where they're gonna take over everything, then I don't know. That's scary. That's a scary thought.
I know my sister-in-law has her degree in like software programming and she cannot find a job because companies just hire outsiders that are a lot cheaper,
Yeah.
unfortunately.
Not only that, they want you to have experience too.
Yeah.
You're like a
Yes.
fresh grad. They're gonna be
Yeah.
like, this kid doesn't know what he's doing.
And they do at the end of the day, which is crazy.
Right.
Mhm, mhm.
Oh my God.
But what are
Maybe-
you showing us?
This is
Oh wait, what's that?
I think, one of the best ways that we can use tech to help. Is this going to work in Firefox? Maybe not. But I'll send it to you. No, we're just gonna have to open Chrome. Because this is a lame demonstration if it doesn't work.
Everyone watching the
Yeah.
recording.
You're gonna hear about pickle juice. Pickle
Oh
smoothie.
man, I forgot about that. There we go. Okay, this is a lot cooler now. So this is showing you further on in the class, we're going to look at like where the formats are for different like vowels and different consonants. This is showing you for R. So if you say and you're trying to get your R, that second format for the R, to be at this gold line right here. There we
Oh wow.
close. So that's what you're working on.
I have a question.
Yeah.
How would you articulate the letter N, like the sound?
Oh.
Because, okay, I'm a para,
Okay.
and in my school district, we do what is it called? What is it called? It's Spalding. I'm not too sure if you're familiar with that.
I've heard of it.
Yes. So we're teaching the kids like sounds and stuff. And so for the letter N, she puts her tongue between her teeth and she's like, oh, like, yeah. I'm thinking of the letter L.
Okay.
But no, yes. And I'm just like, is that how we're supposed to say the letter N? Like, are we supposed to show the kids to say the letter N like that?
Oh man. I mean, I'm on alveolar ridge, right? Like behind the teeth. for-
Yes.
Yeah.
Mm.
She's
Mm.
on the teeth?
Yes, that's what I was so confused, and I don't want to like
Mm.
overstep and be like, "Oh, well, that's not how you should teach them."
That seems
But
wrong, but that's
yes,
also like a Dr. Bruce, Dr. Weinhold
yes,
thing.
I was
Yeah,
just
because I'm doing it
curious.
myself, and I don't.
Yeah.
But then, if I'm putting my tongue between like my teeth. My tongue still tries to touch the alveolar ridge.
Right.
It still tries to touch it. So even though my tongue is like in between the teeth, somehow a little bit of behind, not
Like
on
the
the back
back
of,
part, right? Like
Yeah.
it
yeah,
hits.
like on the tip of my, yeah, it still tries to reach the alveolar ridge.
So I wonder if
Yeah.
it's trying to like show the kids, like you can see my tongue, so if you can see it, like if you're doing an N the normal way, it's just like I can't see what's going on in there at all. And so if you do this with the tongue out, maybe they can kind of see where it's supposed to be. I don't know. But
Go get him, March.
yeah.
Wait, sorry.
Yeah, I was confused. I was just like, that seems wrong how you're teaching them. But I feel like Spalding should like be studied because it's a lot.
Go get him, March.
Yeah. Yeah. Now I'm gonna look it up and see if it's like, you know, a weird thing scientifically.
I don't know if they trained her to say it like that, but like when I took the training, because we test the kids on it, so it was just like a couple of things. So it's like the letter A is a, ah. Those are the three sounds that the letter A makes.
Right.
and so on and so forth, but they don't show you how to actually like the placement and stuff.
Okay, that's interesting. So she's kind of maybe come up with
Yeah, I don't know. I'm like, it's a little wrong because you don't actually produce the sound like that, but
But do
Okay.
you hear her actually saying the N word? Like, yeah,
yes, the
that's
sound,
crazy.
yes. But you know what? I think she's not from here. She's Filipino?
Hmm.
Oh, well, that could be a difference.
Aw, I should have asked my Filipino brother-in-law,
Yeah, you should. I'm
and now
curious
that
to know if there's a difference because I know that. So, for Hindi, there's a few different ways of doing an I think. I think it's and then there's a couple different R's as well. Oh, there's retroflex R and regular R. That's what it is. And we hear it as the same thing. Like it's just totally normal to us. It's like I don't know which one you're doing. Um, and in Hindi, it's two completely different speech sounds. So it could be something like that, where it's just like a cultural thing that the N is slightly different, maybe.
yeah,
Or she's weird. I don't know.
yeah. I'll definitely ask my brother-in-law.
Yeah, I'm really curious to know the answer to that question.
In the next Zoom office, I'll definitely bring it up and say, I
Okay,
know I know the answer.
good. Okay, I'm looking forward to this. This is gonna be great.
Hmm.
Yeah, sorry guys. I was just curious. I was just like, okay, let me ask an expert over here.
No, you don't. Well,
Eh.
not an expert on that, but you don't have to be sorry. That's a fantastic question. You should hear in my in-person classes, like we talk about crazy questions in there for like a long time. So this is good.
Well, now I'm trying to think about the end.
I know I'm
Now I'm
stuck on
really
it too.
thinking. I'm very stuck on it. Uh, are we gaslighted into thinking that we are pronouncing the N wrong?
I'm pretty sure we're doing it right.
No, I know.
It's
Hmm.
just like, is it a technique or cultural, or is she just wrong? But yeah, I don't know.
Yeah, but she does have like an not too strong accent, but she does have an accent. So like some of the words that she says and the kids like mock her, like even with
Ah,
her accent, and I'm just like, because they're kindergartners, so they're like, oh, this is how I'm supposed to say this word, and I'm just like, oh no.
Oh my God.
now they've all got an accent.
For real.
That's karma if they want to make fun of her.
Right?
No, I don't think it's
Exactly.
intentional, but she's like, okay, repeat after me. And, they repeat.
Okay.
And yeah, they
Oh.
think that that's how you're supposed to say it, I guess.
uh, they'll be fine. That's funny though.
That is.
Yeah, that's I was like, no, not intentionally. They're kindergartners. I don't know, but
Yeah.
yeah.
Oh man. That reminds me of so I grew up in Arizona, but then I moved to Alabama when I was in kindergarten. And I had like a super strong Southern accent for a year and then came back to Arizona and it went away. But it's kindergartners pick things up quickly, man.
Yeah,
Mm.
they do.
Some of them. I mean, I worked with kindergartners for like 3 years now, and I'm just like, eh. Towards the end of the year, yes, they do, but instantly, like, well, this group of kids, they're COVID kids,
Oh
so
Oh
yeah.
yeah.
there's just like it's either they know or they don't know anything.
Wow.
Yes. And I have one student, I was just like, what do you do all day? And she's like, oh, on my tablet and playing with my Barbies. And I was like, oh, you need to have mom practice with you.
Yeah.
Like she cannot identify, I don't even think she knows how to sing the alphabet. Like,
Oh man.
yes.
No, no. You know, my sister worked for a preschool and she also had a lot of trouble with kids who, what was it, Alexis, that have trouble with speaking or with she also thinks that children who were born in COVID have struggled a little bit when it, like exactly what you said.
Mhm.
Um with I think, well, reading, I think you said something along the lines like that.
Yes, it is reading. Actually,
Being
with
social.
math, they're pretty good with their numbers, but it's reading that is not clicking with them. Like they can't identify letters at all.
Huh. That's weird.
The COVID
Mhm.
kids need to be studied.
I
I'm calling it
agree.
right now.
Hey, no, my sister has something to say. I said the same thing. Because I don't know. I also we also agreed because you know my sister as I'm taking these classes and she tells me about when she used to work at the preschool and everything that the kids were saying wrong or with their reading and stuff. They're great socially. They could play. They love to play, but they don't get enough academic as in like reading or like writing is only they're not gonna write. They're like what, preschool, I think? Like 2 years old. Okay, yeah, they're not gonna write, never mind. But even at age 2, they're still not pronouncing their a few things correctly. And
Hmm.
so she always says they're COVID babies, Mickey. They're COVID. I'm like, well, maybe that's not true. But then if since you guys are saying it, I'm like, oh my god, maybe it is true.
Yeah, because my son, he was born in 23 and he like talks like good and but my niece, I think she was born in I don't know if it was COVID. You know, COVID was 2020.
Yeah.
I don't know. She's a little bit older than him and she still like cannot talk yet. And it's weird because supposedly girls are supposed to be more advanced than boys. So
Yeah.
I'm like, this is strange. And I had told like my sister-in-law, I'm like, are you gonna put her like in speech? Because I think she's like 4 years old and she still is just like babbling. It's
That's
strange.
really, yeah. That's pretty delayed.
Yes.
Yeah.
I don't know, but
Wow.
yeah, COVID kids need to be studied.
Wait,
I
so
agree.
so professor, if we were to go back to your 205 class when you talk about like autism and all that, how come people get confused with people with delay speech, developmental language disorder and with like what, why is it that do they all intertwine? I know delay speech does not relate to autism, but like why do people get confused with the
I think
two?
they associate them with each other.
Mm,
Exactly right. Yeah. I mean, one of the hallmarks of kids, especially younger kids for autism, is not talking. And it's you have to get older before you see some of the other behaviors come out. And so then if you're not talking, you can get like kids who come from Uganda who like don't speak English. They're going to be quiet because they don't speak the language. So then that gets interpreted sometimes as like, oh, this kid's autistic. Kids who don't
Yes.
just have speech delay, they're like, oh, they must be autistic, but they're not. You know, like it's just this is a symptom, and they get over applied to autism and not to a lot of times what it actually is.
I had a student last year, her parents are from Africa, so she has an accent and they have her in speech, but I'm just like, I don't
No, totally should not have her in speech. I mean, unless uh in her initial language she also has speech issues, then she should be in
I
speech.
don't
But if
understand
it's
like it doesn't make sense so, like smart and I'm just like she just has like
Oops. Am I lagging?
No, I think she accidentally muted herself.
Oh, okay. Well, shoot.
Her kid's probably screaming. No,
Yeah.
mine brought me a pops or a lollipop earlier.
That's very nice of
That's very cute. Like, here, mom, have a snack.
Yep, here it is.
Long night studying, gotta have
Yeah.
the sugar. That's yeah.
He knew what I needed.
Yeah.
Um, anything else we should?
I think aside from what we talked about,
Okay.
that's all the hidden stuff. There's no super crazy stuff that's gonna show up. If you want to cram a little bit more, like go back through the knowledge checks if you have some run-throughs of those left, and the practice sheet, math practice videos. Other than that, yeah, pretty good. Should be pretty straightforward.
Your
Oh,
tests normally are.
sorry, go ahead. What did you say?
I was gonna say your tests normally are like from like other classes I've had with you.
I try.
Appreciate
I
it.
try to keep them pretty, like, not tricky.
Yeah.
Hopefully this is the least tricky of any of them because there's like less sentence involved. It's just like, here's a thing, calculate. But that's good. I'm glad that you feel that way. There's a calculator in the what is it, Respondus lockdown browser. So there's a couple questions that's like, oh, you got to figure out what's the fundamental frequency if the fundamental period is, 0.047. And since it's closed note and you can't have any stuff because it's watching you, there's a calculator on the screen. So you just like open it in the toolbar and click around on that. And if you know what to do, you'll get your answer that way. I think that's the only math thing that shows up in the multiple choice portion. Is just like the 1 over t equals 1 over f, f equals 1 over t. I'm pretty sure that's true.
Okay.
I have a question. For our module 1, the learning objective 1.6, when would that be graded? 'Cause
Oh,
I don't know if I got that right or not.
I'll try to look at yours. I'll try to grade everybody's soon. Although I have a TA. What's my TA doing? I'll have to talk to my TA. But I'll look at yours, Michaela, and just make sure that it looks right.
Wait,
since
which
you have a question
Michaela's?
about it. I'll look at both of yours. I'll look at all
Okay.
4 of you.
All right.
Let you know.
I'll fix mine if we're talking about the same one of the fundamental frequency.
Okay. I'm
Yeah,
sure my
'cause
TA
I
is
did.
doing fine. I haven't told her to jump on it yet, so it's fine.
Okay.
Yeah, I had emailed you about it. So I'm pretty sure I did get it right, but I'm not too sure.
Oh, yes, I remember. Okay. Yeah, I remember talking to you about that.
Yeah, that was
But
me.
I'll look at it again. Yeah.
Michaela with the K.
Michaela the K. There's so
Yes.
many. There's another one in our class too that's like MAKYLA,
Oh wow, yeah.
there's a lot.
different ways to spell the name.
Yeah. Yeah. Delicia has a question in the chat. You'll be okay. There's no time limit, so go, take it slow. You can do one question and then like come back after a little while. And but you should be okay. Make sure that you pull up the math review videos while you're doing the exam if you aren't sure about something.
Can you go talk as a department again and let us look at our questions after we've done it? Because I feel like,
Oh.
the multiple choice, you can only do one at a time and then you can't go back.
Yes. That
I
is
don't like
true.
that.
I know. It's not
Because then like
ideal.
later I'm like, oh yes. And I was like, oh, I can't go back.
Yeah. I know. It's not ideal.
I know someone had to ruin it for all of us. We get it.
I know. I know. You can look at it. I mean, this isn't what you're asking, but of course you can look at your answers afterwards. If you like email me and we can Zoom and then you can look at it that way.
Yeah.
That doesn't help go back and answer the question that you remembered afterwards though.
Yeah.
Yeah. Also, Michaela, with a K, sorry, earlier one of us was lagging. I didn't mean to cut you off.
Yes, I know. And then my dogs were going crazy barking too. I'm like, I can't hear. Then you're like all glitching. I'm like, oh no, is that me? Or is that you?
I don't know. Sorry about that.
Yeah, no, you're fine. Yeah, I was like, I have 3 dogs. I have 3 schnauzers, so
Oh man.
they're just yappers.
Yeah.
They hear something and they're like, what? Squirrel.
Yeah.
Yeah, I have 2 huskies and 1 min pit, so my huskies are going
man.
crazy right now.
Those are loud dogs too.
Yes. Do they shed a lot? I heard.
Oh my god, you have no idea.
Oh my, no. My dogs are, what is it, hypoallergenic, so
Yeah.
they don't shed, thank goodness.
We eat the fur because it's everywhere.
Oh, no!
Okay, I was just joking. Wait.
No,
we
you
have
weren't.
these-
I'm just kidding.
No, you caught me.
Exposed.
Like it's so nasty because I'm just talking and then I feel fur in my mouth. I pull it out. I'm like, how does that even get there?
Oh my goodness.
I have a
Don't
friend
get
who made
huskies.
a casserole and they had a very anyway, there's hair in the casserole. But
Did you eat it still?
not after I got a big mouthful, like a clump, and I was like, I'm done with this.
I'm
But
full,
thank you.
actually.
Yeah.
Oh my, no.
Well, anyway, sorry, it's good. It's really fun tangents. It's great
Yeah.
talking to you guys. But it's about time for me to go off and work on some other stuff. Any last minute questions?
No, thank you for going over the things that I needed you to. I appreciate it a lot.
Yeah, you're welcome.
Okay, well, good luck on the exam, guys.
Yeah, good luck. If
Have
you
a good
think of
week.
anything else, email me and hopefully I'll get back to you in time. But good luck.
Awesome. Thank
Thanks.
you.
Have a
Yeah.
good weekend.
You too.